Purpose of this video is to illustrate how to tell whether your functionality that you programmed into your model is actually working or not. So we are going to test this model that I'm claiming is working properly. So before we can test whether something's working properly, we have to have an understanding of what it's supposed to be doing. So in this model, you have a simulated battle where red and blue forces can fire at each other. In this model, the red forces are represented as items inside the model. So that's what's being created is the red forces. They are traveling through the model, and blue has an opportunity to shoot at the red forces in this top area here. If the red forces run out of health, they exit the model. After blue has an opportunity to shoot at red. Red has two opportunities to shoot at blue. Now notice that these two areas look different because blue in this particular model is not represented by one of the items. It's represented by some notional number of health points. So we're going to have two different testing strategies because one piece that we're testing involves whether or not individual items are behaving properly. And the other piece of functionality involves whether or not multiple items are interacting in a way that we expect, which is in this case, decrementing the blue health. So we're going to test one thing at a time. We're going to first test blue attacking red. So when you have a model that's doing more than one thing, when you do the testing, you normally want to try to isolate the functionality that you're testing from the rest of the functionality. Otherwise, you can either have unintended side effects or you simply interfere with what it is you're trying to test. So if we want to test whether blue fires at red properly, then we don't want blue to die before we can finish doing this testing. So we want to set the amount of blue health remaining to be super high, so effectively blue can't die. So blue health to start with is set in this holding tank by this initial value. Here it's set at 25. I'm just going to set it at 2,500. So just again, ridiculously high so that there's no way blue can die before I get done doing my testing on whether blue can fire at red properly. So that's not going to prevent red from firing at blue, but effectively it doesn't have any practical effect on blue. So that allows me to isolate that amount of functionality, preventing the simulation from terminating earlier that I want. Okay, so now that I've done this, when I'm testing a single item, so here I'm testing the functionality of each item as it goes through. So I'm effectively checking the functionality of each individual item. When you're trying to check the functionality of the behavior of an individual item, it's really important that you're only running one item through the model at a time. If you run more than one model through the item through the model at a time, then it becomes much harder to figure out whether you're really getting the desired behavior because any plots you do will be mixing the data from several items and it's very hard to see. So we want to be sure now we're only running one red at a time and the reds are created inside this create block. So we're opening that up. And we're going to check the options and we can see that only one maximum item is generated, one item quantity is one, only one creation event. So we're only creating one item. Okay, so we've increased the amount of blue health. We'll make sure that we're only creating one item. And now what we would like to have happen is every time blue fires at red, we would like to see potentially based on this probability that some number of health points are being decreased and eventually red will be exiting the simulation. So that we want to see that decrease in the bad guy health points remaining. So in this particular model, inside the equation block, we can see that only one health point gets removed at a time. So that's the behavior that we expect, 1 point at a time, maybe. So each time we fire, we may have actually missed, and therefore we're not going to see health points getting removed every single time. So we want to check to see what our probability of kill is here, so that we have a 50-50 chance of hitting. So we expect to see that sometimes we're going to hit and other times we won't. So now we need to show that happens. And to do that, we're going to use a plotter block. So we're going to use a line chart. So we pull that over from the chart library, and we want to see how many bad guy health points are remaining. So now let's go ahead and run. We're just going to run with the animation off so that it will happen quicker. And now we're going to take a look at our plot and see what happened. So I can see here that it looks like I'm decreasing down to 0, which is the desired behavior. And if I look at the data, I can see that sometimes the value here in the number of health points is not decreasing. And so therefore sometimes I've hit and sometimes I've missed, which is then the desired behavior. So if I were going to write this into a report, I would show this graph and then explain what I just said, and that demonstrates that I'm getting the desired behavior when I'm running through here. Okay, so this then demonstrates that blue is firing at red with this particular grouping, and that it's actually working properly. So now we want to move on to red firing at blue. So when we have some aggregated behavior blocks, we want to test with more than one block. So there's a couple things. When we're testing on red fires at blue, we want to make sure that our reds are not going to be dying on us, right? We just want to keep them firing on blue all the time so we can tell what their behavior is. So we want to go in and temporarily set this constant value to be 0. So we have no probability of kill. And just a warning here, in that any dialogue inside the blocks, if there's anything connected to it, that connector is going to override whatever you input. In this case, there's no connector coming into that block, so whatever the value is in the dialogue will stick. If you ever find, hey, I thought I typed something into one of these dialogues, but it isn't sticking, it's probably because there's a connector on the outside that's overriding it. So you just want to be aware of that. So we've set blue PK to 0, so we should see, we can also look at this graph afterwards and we'll see that even though bad guy, that there's bad guy passing through there, but hit points are never being deducted. The other thing is we want to make sure that we're aggregating behavior from more than one red unit. So we have to go back into the create block and then make sure that we have behavior from more than one unit. We want to set the maximum items being generated as, let's say, 3. And we can have 1 at a time, but in this case, it doesn't really matter, but we just want to make sure that we are generating multiple red items. Okay, so that should generate multiple reds for us. We can run with the animation on for a little bit to make sure we actually see multiple reds happening. And we already have a plotter hooked up. So the plotter is showing us the number of points each time that's being deducted that we go through. We're also seeing the aggregate number of points in that blue health remaining, and we should see that decreasing. So each time we go through this with this plotter, we expect to see some number of hit points being taken off sometimes, again, not all the time, from both of the weapons. So notice that we're checking both the weapons at the same time and that we should aggregate into the amount of blue health remaining. And we can check that using the plotter and the data from the plotter. So let's see, we've set the blue PK to 0. We've set multiple reds, and we've set the plotter that we expect to show what we expect to get. Okay, so I'm going to turn the animation on just to make sure multiple reds are being created. I have a lot of blue health here. I'd like to see also that the blue health is actually causing the, in this case, it isn't going to cause the program to terminate. So what do we really expect to happen here? Well, we expect to at some point run out of blue health. In this case, the blue fires at red weapon and there's no probability of kill, so we're just going to continue to recirculate. Now, if we want to see whether or not the blue health can get down to 0, we have to set that to a more reasonable value. And notice here, tank contents are not allowed to be negative, so, and we would expect there's not really, negative health is not really a thing. So we would expect that to go down to 0 and stay there until the time runs out on this simulation. Because again, the reds in this simulation aren't able to die because we've set the probability of kill to be 0. We do want to make sure that we have a probability of kill here that is not 0. So we're going to show it. It's going to set the probability of kill to a distribution. For testing purposes, we probably don't want to do that. We probably just want to set it to be a constant value. Okay, and we want it to not be 0. So we're going to set a 50% probability of kill for each of these. And that should set us up to be able to do the testing. So let's go ahead and save this, and then let's run. Okay, so now I can see, if I want to see that I have multiple items created, I can open up this Q block. So I can open block dialogues while things are running, and then I can see at this results, it's actually created 3 items. Okay, and ExtendSim has stopped working, which is definitely not the desired behavior. So I'm going to go ahead and restart. Handily, I saved before I started running, which is always a good thing. Okay, now I should be able to just go ahead and run this again. So again, it's running normally. I don't really need to run it with the animation on now that I've kind of gotten a good feeling for what's going on here. Okay, I can run now with the animation off. And so it runs in a flash here. And then now in this plotter, it doesn't really look like anything's happening here, but what's happening is I actually have a scaling problem, right? So compared to the 2500, I'm really not losing any health here. So there is an auto scale X and Y. I'm going to auto scale Y. And notice that that really isn't happening. So to be able to see anything, I can go to the data. Now the data does show me that I am actually seeing the desired behavior. So we look at what's happening from weapon A. You know, I'm losing variable numbers of points as I go through here. Weapon B, I'm losing variable number of points as I also go through here. And then the blue health remaining, which is actually the contents of the tank. So that's the last trace, the contents of that tank. I can see that the contents of the tank are indeed decreasing the way I think. So even though the graph isn't fruitful because I have so much there, that is showing me what I need to know. Now, if I want to really know if it's stopping at 0, I'm going to need to set that initial blue health back down to 25, which did not stick. Or let's just set it to 10. And we just want to see it go to 0 and stay there. Okay, so now when we see the graph, notice here that we can actually see something useful. And so notice the black trace, which is the contents, is going down and staying down, where the other two traces telling me what has happened, you know, at each point in time, I have a variable amount of damage being subtracted. Once it stays down, though, no further action is happening on the health points, which is exactly what I'm expecting to see. So this leads me to believe that my model is actually working properly. And if I were to, you know, submit this for a paper, I'd be showing a picture of this discrete event plotter, maybe the data here, and then explaining, you know, what I've just said about how it was set up, and then why this demonstrates that I'm actually seeing the desired behavior. So this ends the tutorial on how to do some testing.